Hit me with a bruh if y'all can hear me. Boop. Y'all make sure y'all join that Discord server. Not that Slack, because that's for work. Here's Johnny. Make sure these routers are awake. Come on, router 1 and router 3. We're using the same topology as yesterday, y'all. Y'all give me a second. Give it some time for some people to tune in. We are going to be doing challenge lab number 2. Again, we're doing static routes and ACLs again. So it's pretty similar to yesterday's lab. Got PS in the building. Shout out to you. Dave W, appreciate you for tuning in. This guy is going to be, let me bring up the topology again. It's the same thing as yesterday's lab, man, except they just kind of switched it up with some of the tasks here. So let me bring that up. Where's that at? Y'all give me a second here. It is under this right here, but I wanted to bring it up in Paint though. Open with Paint. There we go. Got our lab. This is going to be on page number, let's see here, page 475, challenge lab number 2. Y'all know we're at the tail end of this book here. As you can see, the router on the left is router A. Make that a little bigger and thicker. Pause. Router A. That guy's router B. Y'all can hear me, right? Let me make sure y'all can hear me. Hit me with the, oh, y'all can hear me. Good, good, good. So, guy on the left is router A. Guy on the right is router B. I'm gonna go ahead and do that while we wait for some people to come in. Other guy's router B. Router B. We only got 4 tasks for this lab. We're gonna be configuring these loopbacks, that loopback right there, that loopback right there, that physical interface, this physical interface, that loopback, that loopback. It's a whole bunch of circles here. Got V McMillan in the building. Appreciate you for tuning in. Y'all gotta excuse me here. I was eating some ice cream. I made a pit stop at the damn store. I had a craving for some ice cream, man. Just messed up my whole damn diet. Give me a second here. I ran 3 miles yesterday. ran about 3.5 miles yesterday. This morning, did my little ball handling drills for basketball. 2 rounds of that. I don't think I did any dips or anything, or push-ups or nothing like that. And fucked it all up with some damn ice cream. 2 big-ass bowls of ice cream today. Anyway, while we are waiting for some late tuners, some late people to come into the stream here, let's see what we got on the news today. We got, come on, what's going on with this thing, man? Weekly internet check. Health check, rather. Looks like global outages across all three categories jumped from 252 to 263. What else we got here? ISP outages jumped from 180 to 284, up 58%, while in the US, ISP outages increased from 98 to 175. And yes, we called in some tickets last week for one of our ISPs. It was I want to say it was one of our backup routes or our VPN route. I mean our VPN router. I can't even remember, but we had to open up a ticket with them. Yeah, ISPs had a rough week last week, man. Worldwide cloud provider network outages declined from 14 to 12 outages, but the US they increased from 1 to 2. There are 3 notable outages this week. On May 20, Slack experienced an interruption. That's weird because I didn't notice it. And we use Slack at work. Coinbase experienced an interruption on May 19th. I have the app, but I don't really use it. I typically use Robinhood for my crypto investments and stuff, so I didn't know anything about the Coinbase outage. And also Hurricane Electric experienced an outage, divided into 3 instances over an hour and a half, affected users across countries including US, Australia, Singapore, Hong Kong. And shout out to you, Pete. Did you notice the Hurricane Electric outage over there? They had an outage over there in Australia. That's pretty much it as far as the outages go this week. Anyway, let's go ahead and get started here. I don't know if anybody else is in here that want to get started. Need an ACL deny on that ice cream, man. Listen, man. I had a big ass bowl of salted caramel. I put some Reese's Pieces in it, man. I love Reese's. I put some caramel in it. Put some Reese's peanut butter cups in it. Chopped them all up. Put them in there. Put some more caramel and ate 2 big ass bowls of that, man. Woo! And man, I am feeling stuffed right now. I am still at the 3 o'clock mark for my gallon. That's how I know. I was like, I had that craving, man. I had to satisfy that craving. I'm gonna make sure I do good this week though. The rest of the week. Yeah, I had to reconfigure some DNS addresses on our static IP addresses on our static IP devices. Was it because of a ISP outage, Dave? That's crazy, man. Yeah, ISPs had a rough week this week, man. But I'm gonna go ahead and get started. Task 1 is to just go ahead and do these loopbacks, the serial interfaces, and these loopbacks right there. So I think y'all, for who I see is already in here, I think you guys pretty much know how to do that part. So I'll go ahead and get started on my end. Remember, your interfaces might be different. Mine is serial 000, whereas the topology has just single 0 or double 0 right there. So mine is serial 000 like that, right? Remember, your interfaces might be different. So his IP address is 10.0.0.2/24. So 255.255.0. No, shut that bad boy. We'll do the interface loopback 0. His IP address is 192.168.1.1/28, which is 240, right? Interface loopback 1. His IP address is 192.168.2.1/27, which is 224.224. Right, so I should be done there. Let's run Pete's favorite command over there. Show protocols, man. Shout out to you for showing me that command. I use that. I even use that at work now, man. I'm like, no book taught me that, man. It took somebody from the Fat Finger Squad to teach me that. And meanwhile, you got it from the white paper. It's not no official cert guide or anything like that. So I'm gonna go to router B, do the same thing. Go to global config mode, do the physical interface. I know I've been saying that I'm gonna do this stuff off stream, but let me race through this so that way I know. 10. I said I was gonna do the IP addressing off stream. I have yet to do that, didn't I? I guess I like to at least make pretend I know how to do something, right? I know how to configure IP addresses. Look at me. Loopback 0. IP address is 172.16.1.1/20, which is 240.0. And interface loopback 1 is IP address is 172. 72.20.1.1/22, which is not 240 but 248.252.0.0, and do a show protocols. We got Shamar Smiley in the building. Appreciate you for tuning in, man. Shout out to Shamar. Show protocols. Let's see what we got going on here. 10.0.0.2/24, 172.16/20, 172.20, 1.1/22. So yeah, I think we good there. And he's 10. That's wrong. That's wrong. You see, that's why I'm glad I looked at it. That's supposed to be 10.0.0.1, right? You see that? Y'all let me make mistakes and not saying nothing, man. No, I'm just fucking with y'all. That is 10.0.0.1.1. I'm surprised I didn't get a duplicate IP address error for that one. But he's 255.0. No shut that bad boy. Snow shut that bad boy. No shut. Show protocols. And 10.0.0.1, 192.168/28, 2.1/27. Okay, I think we good here. Let's see if we can ping across now, right? I'm gonna have this guy ping across right here. Hopefully that works. I'm sure it does because it's directly connected to each other, right? So 10.0.0.2. We got a reply, so we good to go there. Task 2, configure static routes with an exit interface on router A. So we're going to configure a static route so it can reach the networks on the loopbacks for router B. So basically, a static route exiting out of the interface of router A to the loopbacks. So we need a static route to this network and a static route to this network right there, right? So let's go ahead and do that. So far, we take a look at our routing table. I'm pretty sure we know what that looks like, but we'll check it anyway, right? Show IP route. We obviously only have routes to the 1.0 network, which is the loopback, and 192.168.2.0, which is the other loopback directly connected through the loopbacks, right? And then we have a route to this network right here, the 10 network, which is right in here. He don't know how to get to over here and here, and that's what we got to do on router A. So obviously we got to go to global config mode, and this is where I got tripped up last time because I was like, oh, static routes, this shit is easy as hell, right? No, we need to make sure we have. Last time I created a host route, and then, but they said networks. That's what I was. That's where I got not necessarily confused, but I wasn't too sure how to create just a route to that specific network, because the network would be 1.0. No, it would not. It would not. So the network is not 1.0. That's where I got confused. So the network address would be 172.16. The magic number is going to be 16. So it's every 16 networks. And that is why, Pete, you said it was 172.16.0.0. Now I'm getting it. Now I'm getting it, Pete. Okay. So it's 172.16.0.0 with a subnet mask of /20. So 255.240.0. To get there, take the exiting interface of serial 000. So we're saying to get to this interface right here, with that subnet mask, take this exiting interface, serial 000. Remember, mine got an extra 0 because my interfaces are different. So that's what we're saying with that static route right there. Right? Y'all with me so far? And now I'm understanding why you're saying it's 0.0. Pete, you talking about the subnet mask? Or you talking about, okay, 0.0 meaning the network. Now I'm understanding it, because I had to do the subnetting in my head and realize the network address is 172.16.0.0. Now I'm understanding it. So I think Browning is challenging us here with the masks, trying to trick us up. Yes, you're correct. That is correct, Pete. Instead of the /24 or the /16, those are easy networks to kind of calculate in your head because they're classful networks. But this is not a classful network. So yes, you're right, Pete. He is tripping us up with that. but that's what it is. That's why they call it a challenge lab, right? So now let's go ahead and create another static route to this network right here. So that we obviously is going to be IP routes, right? That's how we do static routes. And then to the subnet, the network address, I got to do this in my head, right? So the magic number is not 16, not 8, but it's every 4 networks. So it's the same thing, 172.20.0.0, right? Yes, 0.0, I believe, right? Correct me if I'm wrong, but the network address is 172.20.0.0, subnet mask of 255.252.0, exiting interface of 0.000. Correct me if I'm wrong, though, because Pete, you seem to know your subnetting a lot better than I am, or I do. But let's take a look at our routes so far. Show IP route, and now he has routes to the 16. No, my bad. 16.0 network and 20.0 network /22. So yes, I think that is the static routes for those. Let me go ahead and ping across. I don't know if I'll be able to ping across because he don't have a route to get back. Well, he does have a route. He does have a route. It's the 10 network. So if let me see what he says here. We're still on task 2. We only got 4 tasks here. Configure the static routes for the exiting interface on router A so it can reach the networks on the loopbacks for router B. On router B, configure a default route so all traffic for any networks are sent out of the serial interface. So same thing as yesterday's lab, right? If you didn't get to do yesterday's lab, now's your time to catch up. Basically, we're going to create a default route out of router B to say any network you need to go to, take this interface. We don't care what network it is. It could be Timbuktu network, but you need to exit. You need to go any on that network. Take that network. Take that exiting interface right there, right? You need to go to this network right here. Take this exiting interface. That's what we call a default route. So basically, any traffic that come in here, and you don't know what the hell to do with it, send it out of this interface. That's what a default route is. I like to. This is the example I'd like to use for default routes. Let's say you're trying to get to LA, right? I don't know, for some reason I always like to pick LA as a destination city, right? But you live in, New York, right? You don't know how to get to LA, specifically how to get there, but you know how to get out of your neighborhood. You know this road right here take you out of your neighborhood, right? The gate opens up, you pass security guard by, you leave out of your complex. You know how to get out of your neighborhood. That is called your default route, if that makes any sense, right? From there, you take this road to that road to that road to that road, whatever, who knows, but we know how to get out of our neighborhood. That is the default route. So that's what we're going to do on router B. So I'm going to go to router B, and go to global config mode, and we're going to say, and to any default route is this quad 0. That's how I like to call it, the quad 0 route. So IP route, and you're saying 0.0.0.0 to get to any network with the subnet mask of 0.0.0.0. Take the exiting interface of 0.0.0, which is take this. If you don't know what the hell to do with this traffic, we don't have a route to that network, send it out of this interface. So we say in serial, in my case, 0.0.0, like that, right? And then when we do a show IP route, you'll see that route in the routing table just like this right here. It's gonna say gateway of last resort is quad 0 to the network quad 0. That's basically saying this is the last resort. We don't know what the hell to do with this traffic. You know, this is like just in case of emergency, break glass kind of thing. Send the traffic out of this interface here. That's what that is, right? That make any sense? Pete said looks good to me. Okay, good, Pete. Subnet looking odd to me, but maybe me. Which subnet? Let me know which one is confusing you or which one you think I got wrong. But also, another thing to point out about this default route is that it is indicated right here, right? This S, when we look at the legend, lets us know it is a static route. The star right next to it lets us know it is a candidate default. We might have some other routes that could be considered a default route, but this one, it will be a candidate. So like we might have some other routes. Like I said, there might be some other routes that we could use as a default route, but this is one that we were specifically going to use as a candidate default. That's what that star means, right? And quad 0 out of 0, 0. So now task 2, the second part of it says to ping all networks to check connectivity. So basically, we're going to just basically check from that router, ping that, ping this, and from this router, we're going to try to ping this and ping that, right? We already checked from here to there, right? We already did that, right? Because they were directly connected. Remember earlier we pinged it, right? Where did I do that at? Where did I do that? Where that at? Where that at? We did that up here. Remember earlier in the stream? And for those of you guys that just tuned in kind of late, but we already checked connectivity because there's a physical cable from there to there. So we already checked that already. We already checked from here to here. Now we're just going to be checking these loopbacks right here, right? So from router A, let's ping. I'm going to do this one right here first. And then I'm going to do this one right here, right? Ping 172.16.1.1. 1.1. We got a reply. Ping the other one. Get on our knees, pray to the network gods, and ping the second one. We got a reply, 5 exclamation points, so we're good to go there. Now let's go to router B and do the same thing from here to there, right? Go to router B and ping, and that should work because we already have a default route to all of 192.168.1.1. That works, and 2.1, right, which is right here, right? 2.1. We just did this one, 1.1. Now we're gonna do this one, 2.1, right? So .2.1, and we got a reply. Good to go. So we got connectivity. We got bidirectional connectivity. I guess in this case it's quad directional connectivity. Sorry for my dad jokes, but you're right. It's all good. Jason Cliff, the network address of 16.1.1/20 is 16.0.0. So that's the network we're trying to get to. Exactly, Pete. And I wish like Pete pointed that out yesterday in yesterday's stream, and I just was like, how is that the net? And I don't understand, how am I forgetting about subnetting? Like, we have to know the network address for some specific subnets and stuff like that. And that's what he was trying to point out yesterday. And in case you guys get confused with that, I usually use this app, I haven't used it in a minute though, called Practice Subnetting. If you have an Android, God forbid you got an iPhone, they might have it on there too, but Practice Subnetting is the app that I use. It'll be you'll see a blue, like a dark navy blue box with an S on it. It says Practice Subnetting. It gives you random IP addresses, and you got to figure out the IP class, the magic number, the subnet address, which is what we was trying to do here. The first host, last host, broadcast address, how to do the subnet mask, insider notation, etc., and vice versa. And then you can change it from private IP addresses to public IP addresses. It's a great app to kind of like work in the mental subnetting. So again, it's called Practice Subnetting. Great app. So task 3, add an extended ACL, what we came to do, on router B. So we got to go to router B. I'm on router B. Y'all run with that like button if y'all like what y'all see so far, man. We might be able to knock out 2 labs with this one. I don't know. But in case you're just tuning in, this is the lab guide we typically use. 101 Labs, Cisco CCNA version 4. I'll be promoting this bitch like it's my book. You can either copy this from 101labs.net, or there's a link in the description box below. It is an affiliate link, so you know I get commission if you do get it from there. But it is quicker to get it that way because it's an Amazon link. It'll take you to Amazon. You can get it from Amazon Prime if you got Prime or whatever. So add an extended ACL on router B to deny all Telnet. So we're gonna create an ACL on router B, right here, right? This is gonna be like the gateway right here, right? I'll put a little gate, I don't know, something like this, right? And we're gonna create that as an ACL, right? What's that? Access control list. Remember, he's like the bouncer at the nightclub. He only lets certain people in, and whatever, right? So he just standing there and being discriminatory. We're gonna deny all Telnet, HTTP, and DNS traffic incoming. So any kind of traffic that is going this way, and it is what is it? It's HTTP. I ain't gonna write all that shit off. Let's just do this. HTTP. What else? They said DNS. and Telnet. So Telnet. I'll just do like that. Let's just do TN. Not Tennessee, it's Telnet, right? So any of that traffic, we need to block all this shit right here, right? Any HTTP traffic, DNS, or Telnet traffic, we need to block that. So we got to create an ACL that's going to do all that on router B. So we're on router B. We're going to go to global config mode. We're going to say IP access list. What else did they say about it before we define what type of ACL and what it's going to do? Ensure that you enable Telnet on the router for the VTY lines for testing. Then he says test your ACL on router B by telnetting from router B, telnetting to router B from router A. So after we create this ACL right here, they want us to telnet to router B, test it, and hopefully it gets blocked if we did our ACL correctly. So that should be easy. But that's what I thought yesterday, right? Until I ran a couple snags, right? So we're on router B. We said any traffic. So we don't have to specify any kind of network. So that should theoretically be easy. We know it's going to be an extended because extended is the only way. Like standard, you can't block specific protocols, right? Extended, you can. You can block Telnet traffic, you can DNS, you can do, different port numbers, etc., etc., etc. So extended, we're going to call it... right, because we got to name it here, right? Yes. So I'm gonna call it block hash dash DNS dash HTTP dash what he said, Telnet. So when I say block that, so now we have to actually create. Now we're in named access control list mode, and now we got to make those rules. So first thing we got to do is we know we got to deny. So that keyword right there lets us know denies the keyword, right? And then we got to do the protocol. In this case, it's Telnet. Well, we got to do one for each line. You can't put all three protocols in one access control entry. So we have this list, but we have to create a rule to block DNS, block HTTP, and block Telnet. So we got to create 3 different rules because of that right there, right? So block, you can't do Telnet, right? So we got to do TCP because there's a TCP type of traffic. And they didn't say what specific networks. They just said any. All they said was, this is what they said. Add an ACL to deny all Telnet, HTTP, and DNS incoming. So let's do DNS first, right? So block, I think DNS is UDP, right? I think it's UDP traffic because you can't do DNS right here. So you got to do UDP and then say any, this is the source, to the destination, any equals DNS. Oops. Is that DNS? Let's see. I don't see DNS on there. Domain. So you can either put DNS or you can put the port number 53. In my case, I'm going to go ahead and I'm going to be fancy and put 53. Right? Here's the cool thing about ACLs, right? You do show IP access list. You typed in 53, it changed it to domain, right? Now we need to create another rule to block HTTP, and then one to block Telnet. But before we do all of that, let's do this. Well, we already pinged it, so we already know there's connectivity. And yeah, we already pinged it. So let's go ahead and create another rule for the other two. We did DNS. Let's do HTTP. So deny. I believe HTTP is also UDP traffic. And you're going to say any to the destination of any equals HTTP. Can you do that? No, you can't. So I'm going to do the port number of 80 since I know off the top of my head HTTP is 80. But let me see. What is the named equivalent for that? I don't think it's in here. Nope, it's not. So, but I just know that HTTP is 80. So that's why I went ahead and did that. Why I did that? See, it's not on there. So your interface might be different. You could either type in the port number or type in some of the words if you know them, right? Like DNS, I didn't know DNS would have been equivalent to just domain, but you could just put in the port number like what I did, 53. So we did that already. Now we got to do the same thing to block Telnet, which is a TCP traffic. Any equals Telnet, or you can do 23 if you want to be fancy, right? Do 23, right? We do show IP access list to show our work so far, and we have a rule that's going to block DNS traffic, block HTTP traffic, and block Telnet traffic. HTTP is TCP. No, because if I'd have done TCP, it wouldn't have took that. It wouldn't have took that. So, Professor Black Ops in the building. Appreciate you for tuning in, man. He said, "How's Mama's cooking tonight, man?" We cooking tonight. We was able to ping so far from the loopbacks and stuff, but we're doing static routes and ACLs again today. So, and we're almost done here. We're on task 3. Ensure that you enable Telnet on the router for VTY lines for testing. So let's go ahead and set up Telnet. Yes, Professor Black Ops, we're working with Telnet again today, man. But you know, that's just for simplicity reasons, man. I thought about that yesterday or today at work. Actually, I was like, why am I not doing SSH on these live streams? Well, 1, the book calls it for that, and for 2, SSH just has a lot more administrative work to set it up, right? And it would have just made these labs a little bit longer. So, we're going to enable Telnet. So go to the VTY line 0 through, I'm going to do 15. And we're going to say transport input Telnet. That's going to allow Telnet traffic. We're going to put the password of, I'll put NetworkBruh, bruh 1. And what else are we going to do here? That's going to be the password. Test your ACL on router B by telnetting to router B from router A. So again, we're going to do that again, right? So we're going to telnet from here to there and hope that it gets blocked, which I'm pretty sure it will. So let's see, we're gonna go to router A and try that. Telnet to 10.0.0.2. You know what? I just thought about something. Watch this. I press enter. It's gonna allow me to telnet. Anybody know why it's allowing me to telnet? Why my ACL is not working? That's your pop quiz. NetworkBruh said compliance loves static route. I figure on the Telnet, but yeah, man. Really? So static routes are something that you're more, you're less likely to fail compliance checks with static routes. I would have thought because it takes too much administrative work to have static routes and more prone to errors with static routes that you would fail compliance checks. But I guess I could see why, because dynamic routes are more susceptible to, I guess, being changed or hacked if you don't have authentication set up or whatever. So I guess I could see. Oh, Kobe said it's under www in the list. Oh, shout out to Kobe for pointing that out. I didn't see that. But while somebody's thinking about why I'm still able to telnet and why my ACL did not work, I'm going to see what Kobe pointed out. He said HTTP is, oh, that's right, you could put www, but I don't see it on here. But yeah, I think you're right. I do remember seeing that before though. You put www, you're able to define HTTP traffic with that. That's true. But I don't see it on here for some reason. But I know that HTTP is also port number 80, so that should have worked, but it did not work. Nielsen got it correct. Did not apply the ACL list inbound on router B. Shout out to Nielsen for that one. That is correct. So we got to go to router B and apply that access control list. Now, let me ask you this. Do I need to apply it on the VTY lines, or do I need to apply it on the serial interface, the physical serial interface right there? But shout out to Nielsen for pointing that out. Configure terminal. I'm going to go ahead and put it on the VTY lines, right? Because it's Telnet and stuff like that we're trying to block here. Let's see. Line VTY 0 through 15. And we're going to say access class. And the name of it was block hyphen, what was it called? It was this right here. That was the name of the access control list right there. right? Let me get rid of all this. And then say in for inbound, right? Shout out to Nielsen for that one, pointed that one out correctly. Show IP. Actually, you can't even check it that way. I still have yet to find out a rule or a show command that's going to allow me to see which VTY lines has which access control list. The only way I know how to do that is show run and then section line. That's going to let me know I applied it to the VTY lines. No, right here, and right here, which is what Nielsen pointed out. So now let me go ahead and try to Telnet into it. Refuse. So it did work. I applied it to the VTY lines. Pete said because www is TCP. Okay, gotcha. Interesting. Okay, good to know. Did you apply to ACL? Jason Cliff, yep, that is correct. And Kobe got it correct as well. So yes, I needed to apply to ACL, and I did it that time as well. I don't think, let me see what he says here. Also on task 3, he says, testing the HTTP and DNS will be a little harder without hosts. So just compare your configuration to mine. So we just got to assume that it's also going to block the DNS traffic. Y'all know I like to keep it funky here. Block the DNS traffic and also block the HTTP traffic. We just going to have to assume that it's going to work because we know it blocked the Telnet traffic as indicated with this message right here, connection refused. So task 4, final task. Add a named ACL on router A. So we got to go to router A, which is right here. He said add a name that we got to do another ACL on this guy right here. So it'll go to router A and put an ACL right there. What does he want that ACL to do? He said so that only hosts on the network 172.16.1.0 network, so basically only these hosts right here, can telnet to hosts on 192.168.1.0. So only these hosts can get through that ACL and telnet to this that network right there. Right? Telnet. Y'all roll me with that like button, man, and subscribe to your boy, man, if y'all like what y'all see so far, man. After we wrap up this book, we're going to move on to the CCNP topics, man. So harder shit than this, man. There's going to be more than 2 little routers with these simple-ass ACLs and static routes and stuff, man. We're going to get into more complex shit than this, man. We have like 4 or 5 routers sitting on top of each other, EIGRP, route redistribution, all kind of crazy shit, right? So, and then he says, ensure that you enable Telnet on the router. So let's go ahead and enable Telnet on this router right here so we don't forget that, right? Line VTY 0 through 15. We're going to say transport input Telnet. That's going to allow Telnet in. And we also want to create a password of, let's do NetworkBruh 1. So much for a secure username, right? No, I don't use that username, so don't be trying to hack my shit here. What else he said? And we enable Telnet. Only hosts on that network can Telnet to that network. So let's go ahead and do that. Let's go ahead. We know we got to create he said a named ACL, right? So we're going to say IP access list is going to be a standard, I mean, not a standard one, but an extended one, right? Because we have a source and a destination. Plus they defined the protocol, right? Which was what? Telnet. So that lets us know it has to be an extended ACL. And we're going to name it allow, at least I am, allow Telnet. And then only hosts on the network 172.16.1.0. So right there, it lets us know, being that I got a green arrow right there, that lets us know permit is the keyword we got to use, right? He said Telnet traffic. You can't do the protocol yet, so you have to define the how do I say is that the type of protocol it is. So in this case, it's TCP traffic, source of 172.16.0.0 network, subnet mask of /20, but we don't do subnet mask, we work wildcard mask, right? So it's the reverse of that. So that means this is going to be 0.0 dots. The interesting octet will be 240, right? Yep, it's gonna be 240. So you got to do 255 minus 240, which is 15, and then last number is gonna be 255. So that's the wildcard mask right there, right? And then that's the source. Now we got to define our destination. So this is the source right here, and the destination is here, right? Just remember that when you write ACLs, it's permit and or deny, and then the protocol, source, then destination, and then the actual protocol. So in this case, destination is 192.168. Fat Finger Squad in the building at 1.1. No, he said networks, right? Yes, 1.0 network. /28 network. Okay, so hold up. Hold on. Let me make sure I do this correctly. Any questions so far? Did I lose anybody yet? I know this is just like, you know, just access control list. This is a simple Telnet access control list, but you know, there might be some newbies in here that's not sure of what's going on. We got some smart people in the chat room that can answer your question though, if I can't get to it. But what am I doing here? I needed to create a rule. I needed to define this destination right here. It's 1.1, but I'm gonna put the network address. So in this case, it's 1.0. Yes, it's 1.0 network. And then the magic number is gonna be 16, right? Yes, 16. So that means the wildcard mask is 000 dot. What's that? 240. So that's also .15, right? Right. Let me make sure that's correct. 255 minus, because it would have been .240. So yeah, 15. So 000.15, and then EQ for, and then the Telnet. So you got to do Telnet right here at the end, right? Y'all with me so far? Did anybody lose anybody? Did I lose anybody? Let me show y'all the access control list that I just did. So we'll just do as a quick review, right? So I created the access control list and named him Allow Telnet. We said, I didn't put this 10 here. Notice I didn't put that in. That's the sequence number that, if I put another rule, it's going to put it as rule number 20. I put another rule, it's going to put it as rule number 30. They just do that by default. So it added that automatically. We're going to say, we're going to permit TCP traffic, right? You would think just put Telnet here. No, it doesn't work that way. You got to put whether it's UDP or TCP traffic or ICMP. It depends, right? And then the source, which in this case is this right here, but you don't put the exact address. You have to put in the network address, and then the wildcard mask for it. Then the destination, which is this right here. But remember, the network, and then the subnet mask, or actually the wildcard mask, which is the reverse of a subnet mask, and then you define the protocol equals, and then you can put either the port number, which in this case would have been 23, or the actual protocol, which is Telnet. And that's what that rule does, right? So now let's go ahead and try to Telnet into it and see if that worked. So that means theoretically, if we try to change the source interface to say this right here, that theoretically should get blocked if we did our ACL correctly, because that's what he said too. Test your ACL on router A by trying to Telnet from both loopbacks on router B, and that's exactly what he wants us to do. So we go to router B and Telnet to the address of 192.168.1.1, right? Yeah, 192.168.1.1, and then change the source interface to loopback 0, right? Because that's what this is right here, loopback 0, right? Y'all with me so far? So we're gonna try to do it from loopback 0 right here, and get on our knees, pray to the network gods, and we got a prompt. The password was NetworkBruh1, and we're in there. Beautiful. We didn't have an enable password, so it says no password set. Now let's go ahead and try to Telnet from loopback 1. So we're gonna do the same thing, but we're gonna change the source interface, right? So now loopback 1, get on our knees, pray to the network gods, press enter, and it did not block it. We got some troubleshooting to do. This should have been blocked. This should have been blocked. So let's take a look at our ACL. Let's go to route 1. Let's see here. You know why? Let's see. I think this right here we need to make it a little bit more granular. I think that's the reason why. What if you need to put a rule in the middle of the list? Good question, Professor Black Ops. If you need to put a rule in the middle of the list, then you could just put a number in between. So let's say you have rule number 10, and then by default, if you don't put a sequence number and you create a rule, Cisco iOS is going to make the next rule number 20, and then rule number 30, and then rule number 40, etc., etc., etc. If you need to put a rule somewhere in the middle, then you could just put rule number, 15, or rule number 25, etc. Good question, though. So we need to fix this. This should have been blocked right here. So we need to do something with this access control list. I'm gonna go global config mode. Let's say no 10. Let's do that. We're gonna get rid of. Actually, we need to go back to that access control list. We're gonna say no 10. That's gonna get rid of that rule. I think we need to make something a little bit more granular because we just allowed everybody to hell into this network. We don't want that, right? Especially with Telnet. Professor Black Ops is cringing over there right now. To permit TCP 172. Let's see. We need something a little bit more refined than the 16.00 network. We can do exact host route, but we want to do a network. What if we do 16.0.0 network, and let's say we said /20. We did. It was 15.255. That should have blocked that other rule. I don't understand why it let him in. Anybody? He said nice, fine. Didn't apply to the interface. Jason, man, listen, man. Shout out to Jason for that one. What the hell is wrong with me? I didn't even apply the damn rule. What the hell is wrong with me, man? Oh, all right. Shout out to Jason for that one. So the rule did work. Let me put the rule back and apply the ACL to this interface right here. What is wrong with me, man? I'm thinking about too much ice cream here. So, this right here. We need to apply that ACL right there. What is wrong with me, man? Jesus. I remember when I first started studying for this stuff, I was like, why is this ACL not working? I didn't apply the fucking rule, man. You got to apply it to the either the VTY lines or the physical interface, etc., etc., etc. So, okay. Now, let me ask you this, though. Do I need to apply it on the physical interface, or do I need to apply it on the VTY lines? I'm going to do it. Last time I did it on the VTY lines. Let me do it on the VTY lines again. And let's see. Line VTY 0 through 15. Let me say transport. No, we did that. It's access class. And the name of the rule was allow telnet. Right? And we got to choose whether it's an inbound or outbound ACL. In this case, it's inbound because it's coming in. Right? Press enter. And shout out to Jason Cliff for pointing that out. But what the hell is wrong with me, man? I just did it on last router. And I pop quiz y'all for that. Y'all should have been pop quizzing me, man. The NetworkBruh over here. Network duh. Show IP. Oh, you can't even check it that way. See, that's what I was going to think. Let's just go ahead and Telnet and try it. Let's go ahead and Telnet and try it. So I'm going to do the same thing. I'm going to try it from loopback 0. That blocked it that time. That blocked it altogether. What if I do it from loopback 1? That blocked the whole thing. Interesting. We didn't want that. Let's go back to that rule. Let's go back to that rule. Show IP access list. It's allowing telnet. This is what I wanted to do. Let's do this real quick. Before that happens, he said, Mama son, to put some cooking on the security, man. Yeah, seriously, man. You are allowing one network, but blocking the others. But what about in this case? I blocked. Oh, can y'all see me? Because right now it says error occurred. Let me refresh real quick because I don't see anything on the stream over there. Might have to refresh just to make sure y'all can see me. Let me know if y'all can see me. Hit me with a bruh if y'all can see me, because I just seen it said there was an error on my YouTube right here. Connect stream. Yeah, y'all let me know if y'all can still see me. But so this time it blocked both of them, and we don't want that. We don't want that. It blocked this as well. And keep talking, Professor Blackouts. Kwame has you on his list. Yeah, right, man. Listen, man. Everybody's on Kwame Brown's crosshairs right now. I make sure, you know, he's taking down all the YouTubers. He don't give a fuck if you big or small, man. Kwame is on a. He got a hit list right now. But let's see. Right now, I'm blocking all my Telnet traffic. That's not good. That's not good. Because let's see. If I try it from loopback 0, that's blocked. I try it from loopback 1, that's also blocked. So let me do this. I'm gonna put it on the physical interface. Configure terminal and do line VTY 0 through 15. And we're gonna say no access class, and it was called block or allow Telnet inbound. And I'm gonna put that same rule and put it on the physical interface. So instead of putting it on the VTY lines, instead of putting that rule on the VTY lines, I'm going to put it on the physical interface of 0, 0, 0. So I'm going to go to interface 0, 0, 0, 0 like that. I'm going to say IP access group. Notice on VTY lines it's access class. On physical interfaces it's access group. But they're both referring to ACLs, right? And the name of it was allow Telnet. Jesus. Allow Telnet. And then we're going to apply that rule inbound, right? So now let's go to router 3 and try to Telnet from loopback 0. That works. So this is good right here. It allowed this to come through, right? We put the NetworkBruh password, which was NetworkBruh1. That worked. Okay, good to go. So now let's try to do the same thing, but we're going to try to Telnet from loopback 1 like that and hope that it gets blocked. Let's Telnet, change the source interface loopback 1, pray to network gods, press enter, and it got blocked. Good to go. So I needed to put it on the ACL this time for it to work. Last time I had to put it on the physical, on the VTY lines. Not too sure why I had to do that, but do y'all see what happened there? Last time I applied the rule to the, where did I do it at? Where did I do it at? I did it right over here. When we did this block DNS traffic right here, we did it on the VTY lines. But then when we did it on this one, we put the ACL on the physical interface. So unless somebody can explain to me why, but I see that let me see. Yeah, this blocked both DNS, HTTP, and Telnet traffic. We put it on VTY lines, and then it worked. But then when we went on here, who knows? I don't know if anybody can explain that to me. But either way, it worked the way we wanted it to. We was able to Telnet from loopback 0, and then it blocked from loopback 1. So it worked as intended. Next lab. We typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. Next time y'all want to follow on, get your copy of this book, 101 Labs Cisco CCNA version 4. You can get a copy of this from 101labs.net, or there's a link in the description box below. Experts agree that we retain only 10% of what we read, but 90% of what we do. So that's why I like doing this stuff from the book and actually practicing this stuff. The solution, remember, after every lab, he has a solution guide, and you can see how he did things differently. He didn't do anything differently. Oh, he actually applied it to, yes, he applied it to a physical interface, but he also added a permit IP any. So not only did he create the exact rule that I did, but he also did a permit IP any, which is what Pete was trying to point out there. I see what you're saying. You said he smoked Dr. Boyce Watkins today. He sure did. He sure did. Dr. Boyce Watkins tried to, drop some jewels to the overseers and say, hey, look, y'all want to take him down for using the N-word. It's just like, yo, come on, man. How you gonna like drop game? Like, come on, man. Like, I don't understand why he did that, man. I don't understand why he did that. But yeah, he came for Dr. Boyce Watkins, and he sure did. But Jason, he said, bruh. Okay, y'all can see me and y'all can hear me good. Because, yeah, it said the stream was kind of messing up and lagging up there. But that was challenge lab number 2. I think we got enough time to do another lab if y'all want. Challenge lab number 3. This should be easy. CDP, banner messages, and NTP. Yeah, let's go ahead and do that. I'm going to go ahead and reboot. Let me see. Does this use the same topology? I think so. Let's see. Yeah, they use the same exact topology, man. We ain't got to worry about the IP addressing or anything like that. Configure the interfaces. You should be able to ping it across. The serial interface only because there's no routes to the loopbacks. Configure Telnet. But you know what? I'm going to reboot anyway. And we'll put that same exact for anybody that want to get caught up. You know, this would be a chance to do some simple, you know, configuring IP addresses and host names and stuff like that. And then that'll give you some practice here. So I'm going to go ahead and reload, wipe these configs here. And we'll do the next lab, which is challenge lab number 3, page number 480. CDP, banner messages, and NTP. This should be an easy one, man. That should be real easy. So I'm going to reload this guy. No. Confirm. And it's going to be the same exact topology. We're just going to configure that loopback, that physical interface, this physical interface, this loopback, that loopback. And then we're going to try to ping across. And then that one's only got 4 tasks. The lab after that, challenge lab number 4, is static NAT. We might save that one for tomorrow. But I'm reloading. Let me know what you guys are using. Are you using the EvenG or Packet Tracer? Or let me know what y'all doing, man. But this should be a real easy one right here for anybody that's like kind of new to this stuff and don't know shit about, you know, loopbacks or whatever the fuck. You could just follow along real quick, man. We're gonna do some real easy stuff right here, and then it might get a little tricky. If y'all want me to explain what, you know, CDP is and banner messages, it's like real like fundamental topics, but we'll go ahead and go over that. The lab objective for this one is for us to configure banner messages, NTP, and CDP on Cisco routers. Banner messages is basically when you log on, it'll give you like a banner like warning, you got to do this or that, or, you know, if you're not authorized to be on this router, blah 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 blah. They got to do that for legal purposes. That's what the banner message is, right? NTP is network time protocol, is a protocol that we use to kind of like synchronize the time on our network. And the reason why we do this is because time is of the essence on the network, right? For example, if you have a host that's trying to, you know, authenticate to your Active Directory server, if the time on your PC and your Active Directory server do not match, it's not going to let you on because it's going to think you're like either a hacker or just a rogue device. It's just not going to let you on. Some devices need to sync their time to another, you know, there's a master clock on the network. That is who everybody reports to get their time from, the NTP server, right? And they use NTP, the protocol, to synchronize their time. So, and time is really important because, like, for example, we rebooted this router right here, right? Let's just say this is the time that, you know, we had a power outage last night, right? And it came back up, and then we go through the logs, and then we like, damn, I can't believe this router this like powered off like that. Well, let's see, what time did it go down? We're gonna go through the logs, right? And we're gonna see if this thing decided to wake up and actually. And here we go. So let's say we rebooted it, the computer. I mean, the router rebooted last night, right? And we go through the logs to see the date and time, right? We're like, oh shit, it rebooted at 0052. That's what? That's 12:52 in the morning in military time, right? If that time was not synchronized using NTP, obviously the logs on our date and time, or the date and time stamps are going to be wrong because NTP was not synchronized. That's what we're going to kind of set up with this. It's not going to really synchronize because I don't have an NTP server on my, you know, on my rack here, but we'll show you how to kind of like set it up and stuff. CDP is Cisco Discovery Protocol. Is basically a protocol that we use to kind of like find other Cisco devices that are directly connected to us. So, excuse me, you could be on this router
he'll see that he's directly connected to another device, but we can use CDP to see what type of device it is, what functions it has, what its IP address is, etc., etc., etc. And I'll show you an example of that. You can turn that feature off, you can turn it on, because CDP has vulnerabilities. They just found a vulnerability about, I don't know, like 6 months ago with CDP messages. There's a way to kind of hack into devices using CDP. So you got to be careful with that. We'll show you how to turn it off and stuff like that. So task number 1 is to configure the topology above, which is what I just said, right? We're just going to configure some IP addressing, easy homework stuff, right? We're going to configure that loopback, this interface, give him that IP address, that interface, give him that IP address with, he's going to be .2, obviously, and he's going to be .1, obviously. We're going to do that loopback and then that loopback, right? If there's any questions you ask, just ask along. Make sure you fire up Packet Tracer. Do this along with us. Don't just watch, because you're not going to learn just watching. You have to be hands-on with it. Kelvin said, hold on, he said, Packet Tracer yesterday, might buy Boss on really soon. Okay, shout out to Pete for that. But yeah, I'm still trying to get a promotional copy from those bastards, man. I've been asking them to let me, give me a copy of the CCNA version. And I'm about to wrap up these CCNA stuff, so they better give me a CCNP one if they want me to promote their shit. But can you describe the difference between CDP and LLDP in ELI5 terms? I don't know what that means, but basically Cisco Discovery Protocol, they just basically use that on devices for Cisco devices. LLDP is for vendor neutral. So it's the same thing. It's just that one is for Cisco and one is for anything else. It's for Cisco as well, but you can use it to find a neighboring Juniper device, a neighboring Aruba device, a neighboring Palo Alto device, etc., etc., etc. So we can have a Cisco router right here, and we can have a Juniper router right here, and these two can kind of like learn about each other's functionalities and IP addresses using LLDP. CDP, you can only do that using CDP. You can only use that, obviously, with, I hope that looked like a D to y'all, Cisco devices. So those two, if they were both Cisco, they can talk to each other using just Cisco devices. And I'm not talking about IP. They can talk to each other using IP, but for CDP messages, well, I'll show you what they look like. So let's go ahead and configure those IP addresses, right? Actually, he's going to be, host name is router A, right? That's how you change the host name. Y'all know how to do that, right? If not, then now you do, right? Same thing with this guy. He's going to be router B. So host name router B. What he said? He said, LOL, NetworkBruh. Funnily enough, I just had to mess around with Kerberos today. Interesting, man. Banner for Compliance has the jail time and fine amounts for federal systems. Seriously? That's crazy. Oh yeah, I think I've seen something like that. But yeah, that makes sense. That makes sense though. Facts on the log for the sync time. Yeah, man. You got to make sure NTP and the time is synchronized on your network. You don't realize how important time is and NTP protocol is on your network, man. He said, thanks for the explanation. Appreciate that, man. Explain like I'm 5. Oh, explain. I never heard of that term. Explain like I'm 5. Sorry, it's a big Reddit term. Okay, now I know. So that's basically the difference. So CDP is for CDP devices, and LLDP is for anything else. You can use LLDP with Cisco devices as well, but LLDP is vendor neutral. Aruba actually supports CDP. Really? Nah, I never knew that. Aruba, that's good to know. Thanks for the fun fact there, Kelvin. Primarily because Aruba ripped the hell out of iOS. Yes, and that's right. Kelvin, I think you're right, because they actually have a lawsuit against Aruba. Right? Is it Aruba? Yeah, I believe that Cisco has a lawsuit against them, though. But I didn't know that it supports CDP. God damn, they don't rip the hell out of their iOS. They even use the CDP message. That's crazy. So, all right, so let's go back to router 1 and do these loopbacks and stuff, right? Go to interface serial. Remember, your interfaces might be different. 000. His IP address is 10.0.0.2/20. I mean, no, he's 10.1. My bad. .1. 255.255.255.0. No shut. Loopback 0. Right now, I'm gonna be doing this guy and then that guy. Right, y'all with me so far? Anybody that's new in here? You know, I know this is some people that this might be easy homework stuff, and we're doing exactly what we did about 5-10 minutes ago. But you know, just in case somebody was just watching, was like, man, I wish I'd have done this, man. Well, now's your chance to get caught up and learn with the network, bro. /28, which would be 240.240, and then we're gonna do interface loopback 1. His IP address is 192.168.2.1/27, which is .254, like that. And show our work with show protocols, and we got 10.0.0.1.24, right, which is that right there, this guy right there. And then 192.168.1.1/28, which is that right there. And the other one is 2.1/27. Man, shout out to Pete for that command, man. I love that command. I can't believe I never learned about show protocols, man. That's crazy, man. For any of the newbies in here, man, keep that one in your back pocket. Show protocols, man. It's better than show IP. I ain't gonna say it's better than, but I like it more than show IP interface brief. And that's a very, very common, like, very useful command. It's just, I don't think it's useful as show protocols, but I digress. Interface serial 000. IP address is 10.0.0.2. Subnet mask of /24.0, right? No shut that bad boy, right? Because interfaces on a router are shut down by default. We're gonna do these two now, right? Loopback 0 and then loopback 1. Easy homework stuff, right? Easy homework. We're gonna get to the hard part. 172, not really hard, but you know, a little bit more difficult or complex or whatever you want to call it. /20, which is 255.255.240.0. Am I correct in saying that? I think so. Interface loopback 1. Finally, his IP address is 172.20.1.1. Subnet mask of /22. He said, if you want to appreciate time, just do anything with kerbals like AD. Oh, interesting. Yep. Hell, Windows DHCP failover fails unless your time is within 60 seconds. Yes, it does. Not even just DHCP, but just authentication in general, man. I remember just having the time wrong on my I think it was the laptop. I can't even remember, but for some reason I just could not get on the fucking network. And then I realized the time was, I had to locally log on to the laptop, change the date and time, and boom, I was able to authenticate to the damn network. So crazy. I remember when I first figured out WRME as a command, my jaw dropped. Yeah, man. I mean, you learn something new every day, man. Shout out to you for that, though. But yeah, you learn something new every day, bro. And this is why I like labbing with you guys, because I learn a lot from y'all, and you know, you guys learn from me. So this is, you know, this is a great learning environment here. Like yesterday, remember I got tripped up with the static routes and stuff like that until y'all was helping me out. So that's why I like doing these live streams more than the you know, pre-recorded tutorials I used to do back in the day. Where were we at here? Oh, the last subnet mask, which was /22. So 255. Not 240, but 252.0. And then show protocols. We got 10.0.0.2, which is that guy right there. And then we got 172.16.1.1/20, 21.1/22. Okay, we good to go. That was task 1. And then he said you should be able to ping across the serial interfaces only. So we should be able to theoretically ping from here to there. And it should theoretically work, right? If we have a, I have a physical cable serial interface, so it should work. We'll ping 10.0.0.2. Get on our knees, pray to the network guys, and we got a reply. Success rate is 100%. So we love to see that, right? 5 out of 5. Task 2. Because, okay, so configure telnet access on router B. So we're going to go to router B and configure telnet on this guy right here. Right? Telnet. Telnet. Y'all want me that like button, man. If y'all like what y'all see, man. We're going to be, like I said, don't worry. We're going to get to the, I've been saying that for the past month or two, right? We're going to get to the CCNP topics. We're going to get to the CCNP topics. Here I am still doing the CCNA topics. It's all good, though. So we're going to go to global config mode, line VTY 0 through 15. We're going to allow telnet, transport input telnet. We also going to, let's put a password of Cisco. Set a banner message on router B as follows.
warning, dash, this is a secure network. Now here's the trick about, so we got to do a banner message, right? The way we do that is banner MOTD, right? That stands for message of the day, right? So when you log on, boom, you're going to get a banner and it tells you, like what Professor Backup said, sometimes they'll give you a warning of what happens if you get on here. You might get fined for this. Here's the possible jail time you might face for unauthorized access, etc., etc., etc. That's what banner messages of the day are, or that's what banners are, right? So what they want us to do is just put warning, this is a secure network, just to keep it simple, right? So, but when you do this, I'm a question mark. Let's show y'all something. It says here, line, right? It says here to type in what you're going to type. But between those two, you got to put what's called a delimiter. So this is going to tell you, this is the symbol you're going to use to start the message. You're going to write what you need to write and enclose that message with another delimiter. So in this example, C is the delimiter. That's why he said where C is a delimiting character, meaning the start and stop part of the message, right? So in this case, they said C, start the message here. Then type in whatever you need to type. In my case, it's warning, this is a secure network. Once you're done with that, you put the delimiting character. I like to put quotation marks, but the tricky part about this is they put in quotation marks in the message. So I can't use the quotation marks because it's the delimiting character. So in this case, I'm going to use the X as a delimiting character, right? Because I know there's no X in that message, right? So I'm going to do X. I know this might be confusing, but some people, I even now, I log into some routers at work and I see they put the delimiting character and they left it in there and didn't realize it was part of the message, and see that in there sometimes. So because they don't understand how the delimiting character works. So in this case, I know there's no X in my message, so I'm gonna put an X as my delimiting character. Rest in peace, shout out to DMX, right? And then I'm gonna put the quotation mark, and he said warning hyphen, this is a secure network. And then he said period, quotation. Now I can put my delimiting character. Boom. So if you look at this, this is my message with the delimiting character outside of them. Does that make sense? Y'all get that part? I know it's just like a simple topic, but this is just so you know how it works. What he said, facts on the GPO. Then I use the DISA sticks on the GPO. Subnetting here for 5 minutes before I have to snooze. 2 a.m. Oh man, I'm sorry, Moose of the Gamer, man. Hey, I'm gonna be streaming all weekend, so hopefully you'll be able to catch me during the day. Typically I stream, if in case you guys don't know, I stream only Monday through Thursday, 8 p.m. Eastern Standard Time. But sometimes I'll stream on the weekends if I have some free time and stuff like that. And I'm gonna do that this weekend. So well, DOD has that standard for a reason. Yep, exactly. I am Fed Security Compliance person. Yep. So Professor Black Ops B, he cringes every time he sees us setting up Telnet and all this simple ass shit we doing over here. So that is our banner message of the day, right? We press enter. We can show our work when we log off, right? So we can log off, boom, log back on. That is our our banner message of the day, right? If you had if I were to put that C as the delimiting character, it wouldn't have worked because there's a C inside my message. So it would have stopped right there, and this would have been my message. Does that make sense to y'all? Right? So be careful with that. Like I said, even nowadays at work, even my last job, I used to see it all the time and see their delimiting character in the message when I'm logging onto a router. Like, who the fuck configured this router, man? Or their switch or whatever. But that's because they don't understand how it works. But that's how it works. So you just got to make sure the delimiting character is where you're going to start the message. And you got to put that delimiting character at the end again to end the message, right? So that is our banner message of the day, right? So now, what else they said? That was task 2. Task 3, set router A. So we got to go to router A. Boop. I know it says R1 for any jackass that come in here, but remember we changed it to router A right here. So leave me alone. Set router A to get the time from NTP servers 1.1.1.1 primary and 2.2.2.2 secondary. So we got to go to global config mode. Remember, NTP is network time protocol. This is the protocol we use to synchronize the time in our network. So we could have made him. They also have you can have a client server architecture with NTP. So we can make him as an NTP server, and then we can make him as an NTP client, or vice versa, right? In this case, he is going to be getting time from somebody. He said from 1.1.1, and then secondary is 2.2.2. These are just arbitrary IP addresses that he came up with. He's just doing that just to show you how to set it up, right? So in this case, he said to get the time from, so NTP, what is it? Server, and then we're going to say 1.1, the IP address of it is 1.1.1.1 as the primary server. So we're going to say 1.1.1.1, but if you question mark, there's no primary keyword. It's actually prefer. So prefer this as your prime. It's basically, that's how you do primary. You put the prefer keyword, that's going to say that is your primary NTP server. In case that one goes down, we're going to fail over to the second one. So, which in this case was 2.2.2.2.2, right? So in this case, prefer like this, right? And then we're going to do the same thing, NTP server, and then do 2.2.2.2, leave out everything else. That's going to let us know that's our secondary NTP server. We check our work with, actually, yeah, basically right there. Task 4, use show commands. Actually, before we even do that, before we move on to this task 4, which is the last task, by the way, show Ntp Associations, right? That lets us know who is our NTP servers. We got this, I forgot what that meant, that little squiggly mark. But basically, notice we got this little legend here at the bottom, right? It's configured as our NTP server, and this is configured as our NTP server as well, right? One of them is our primary. We know that this one is our primary, but it don't really say in here which one is our primary. This lets us know it was the stratum. Notice the stratum says 16 here, right? Remember, stratum is how many hops you are away from your network time protocol server. In this case, it says 16. No, we're not 16 hops away. It's just that we're not connected to it. We're not actually associated to it. Remember, I have my home rack here of routers and switches. It's off the grid. It don't have any network activity or network internet access to it. If I try to ping 1.1.1, it ain't gonna reply. So they just had us put it in there so that way we know how to configure it, just to show you, right? So what we could do also is not only show NTP Associations, we can show Ntp Status. Oops, get that out of the way, and we'll see it's unsynchronized. Stratum is 16. That just lets us know that's as far as you can go as far as how many hops you are away from the server, from the NTP server. We have no reference clock, so we're not synchronizing our time to it, right? And we can obviously we can tell when we show clock, we'll see it is it's not 1:11 right now, but it is the correct date though, right? Because they got that from no, that's not the correct date. That's not even the correct date. So that's even wrong, right? I don't know where you synchronized that from. Maybe I saved it on there. Whatever. Yeah, so all this, none of this is really, it's not really synchronized, but they just did that to show you how to configure it. Task 4, final task. Use show commands to check CDP statistics on neighbor routers. So we do show CDP neighbor. We're on router A, right? And we'll see we have a neighbor called router B. Oops. Come on, man. Fuck, man. Let me close this shit. All right. There. How do you dock that, man? There. I'm going to close it. So, router B is our neighbor. The local interface is 000, which is that right there. And he sees that guy right there as a neighbor. Right? Hold time is basically when it expires, I believe. Right? It sends CDP messages every 60 seconds. And what time? I think it gets rid of that message after 3 minutes. I can't remember. Capability. Remember, we have a legend that we can refer to right here, right? The R stands for that it's a router. It is also an IGMP device. I forgot what that stood for. Isn't that like host? No, that's host. I thought that was like back in the day, host name, the old name for a host. I can't remember. What else? S lets us know it also has switch capabilities. I think it's because I think I have a little 4-port Ethernet module on this device, on that device. Let's see. I think I do. Show
IP interface brief. No, I don't. So I don't know why he labels them as a switch. Probably because of these switch ports right there. That's probably why he also is labeled as a switch, even though it is a router, because it's a 1841, which is a router. And his port ID is also serial 000 right there. So that's his coming. This is my port from router A. That's my port. And then that is his port right there, serial 000. We can also add the details keyword. And then that gives us a little bit more information. So what version of iOS it's running. If it had IP addressing on there. It did, didn't it? It did, but yeah, here's the IP addressing information, host name, outgoing port, etc., etc., etc. So what version of CDP it's running, etc., right? What else they want us to do? Turn CDP off for interface loopback 0 on router A. So on my router A, we need to turn CDP off on loopback 0. So we're going to say interface loopback 0. And here's what I put loopback 3. I did not mean to do that. Let's get rid of that. No interface loopback 3. So get rid of that. And now we're going to say interface loopback 0. No CDP run. No, enable. So that turns off CDP for loopback 0 on router A. All right, we'll do a show run interface loopback 0 to check our work. That's not even in there, so that's not the default command. So, but we did no CDP enable. That turned it off. What else we got to do here? Turn off CDP for the entire router on router B. So we're gonna go to router B. To turn it off for the entire router, you got to go global config mode. Global config mode. I'm glad I turned off the domain lookup there. No CDP run. That turns off for the entire router. No CDP run. Enable is for each interface, because you can turn off CDP for individual interfaces as well. No CDP run. And then what else he wants us to do here? I think that's pretty much it. That's all he wants us to do. What he did with the loopback. Yep, no CDP enable. It just doesn't show up in the... I'm looking at the solution guide here. Yeah, he didn't really do nothing special on here, man. That's it for that lab. Next lab is challenge lab number 4, static NAT. I don't know if y'all want to run that lab or not. Y'all let me know. But I thought about going out and get some drinks and shit. I've been doing enough studying, man. Enough labs and stuff, man. We're going to be labbing all weekend. So y'all fuck with me, man. Dave W makes sense. Moose of the Gamer, thumbs up, man. Appreciate y'all for tuning in and stuff like that, man. I think that's pretty much what we're going to do tonight. The next lab is, again, static NAT, challenge lab number 4. That one only has 3 tasks. Maybe we could do that lab if y'all really want to. NAT is an important topic. Configure. It should be natted to 172.16.1.1, just so we can like wrap this book up, man. Y'all want to do the next lab? Let's go. Let's do one more lab, man. I'm gonna reboot real quick. Let me reboot. Reload. No. Confirm. We're gonna reload this one right here. Reload. No. Yeah, next lab only has 2 routers. It's only 3 tasks. The objective of this lab is for us to configure static NAT. NAT is an important exam topic, so you can be pretty sure it'll crop up. Rather than watch a video solution, blah, 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 he did some test commands. He did some show runs and test commands. Let me see. Did I reboot the other guy too? Yep, he did. We only got 2 routers for the next lab. Let me see if I can copy and cut. Copy that bad boy. One more lab, y'all. One more lab. And then we'll call it a night. One more lab. Where we at here? Next lab. CDP. We did that one. Yeah, that lab didn't really... That lab... He made that one a little harder. He said that was a difficulty rating of 6 out of 10 in the old book. That one was easy. I don't know about y'all. Next lab is static NAT. Here's the topology. Y'all make sure, I hope y'all get a copy of this book too. It's page number 485, challenge lab number 4, static NAT. I'm gonna go ahead and copy and the topology and put it on the lab right here while you guys get your packet tracer. Pete, let me know. You said you're using packet tracer. Can you change the source interface on packet tracer? Let's see. New. Don't save. Boom. That is the lab. Again, we only need 2 devices. Go ahead and configure the loopbacks and stuff just like that right there. Paintbrush. Size is that. Boom. Okay. He's awake. Configure the topology above. You should configure a static default route on router B to send all traffic out of the serial interface. Test by pinging the loopbacks on router A. He says static default route. Now that's easy. So basically, first of all, let's go ahead and do the these interfaces right here. We got to do that loopback, this serial interface, and then that serial interface on that router, right? Y'all with me so far? Router A, router B. So this should be I guess this should be easy. We haven't done NAT labs in about, it's been about 3 weeks ago, I believe we did natting. If you know anything about natting, that's network address translation. It's a way for us to translate public IP addresses to private IP addresses, or vice versa, right? Because remember, private IP addresses are not routable on the internet. So in order for us to have an internal host go on the network, on the internet, it has to get natted, or that's what they say, natted, as if it's a verb. We translate the private IP address to a public IP address so it can be used on the internet. So, like for example, the IP address of your home computer, not something blah 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 blah. But if you go to Google and then type in "what's my IP," it'll tell you what your IP address is. So, like for example, yes, I will tell you guys I ain't gonna tell you what my IP is, but it's a public anyway. So, what's my IP? Let me do that. You just type in "what's my IP." It'll tell you what is your public IP address. So, and for security reasons, I'm not showing y'all mine, but either way, if you just type in "what's my IP," you'll see a public IP address, and this will tell you what your public IP address. So let's get started. He is router A, the other guy is router B. If there's anybody in here that haven't labbed with us in the previous 2 labs, now's your chance again. This is the 3rd time. I'm giving somebody to get caught up here with me, man. I know there's somebody in here that's watching that's like, man, I want to learn this stuff, man. Like, I want to learn. Here is your chance, man. Like, trust me, I wanted to learn this stuff. I wish I had somebody like me on YouTube teaching me this stuff like this, man. Now is your chance, man. And I'm glad, I'm doing this stuff along with you guys, and I get a lot of DMs of people telling me, even comments to this day for some old videos I've done like 2 years ago or even last year, letting me know like, hey, I passed my CCNP exam or I passed my CCNA exam because of your videos. Like, it's what helps me get, keep going and, creating content on this channel and stuff like that. So I appreciate each and every one of you guys, man. Router 3, no, not router 3. He's supposed to be router B. Hostname router B. We're going to go to configure those interfaces that I mentioned, right? Go to the physical interface. He is interface 000. Hopefully I remember how to do NAT, right? And this is why I love labbing, because it's like practice, man. It's practice. It's practice, man. You talking about practice, man? Practice? It's practice, man. Not the game that I died for, man. Practice. 252.0.0.252. Okay, so no, shut that bad boy. I'm gonna go to the interface loopback 0. His IP address is 192.168.1.1. Anybody have any questions or anything, man? Am I losing anybody? /28 is 240. Interface loopback 1. His IP address is 192.168.2.1. Subnet mask of /27, which is 224, like that. Y'all with me so far? Y'all rocking with me, man? I appreciate y'all for tuning in. Y'all kind of quiet right now. I don't know if y'all just really follow along or y'all just ain't got nothing to say or what. But appreciate y'all for rocking with me, man. We gonna do this one last lab here, and then I might go out, man. Router B. Let's go to router B now, right? And do that interface. Y'all see I'm like slouching and stuff, man. I'm just like, let me show y'all real quick, man. Interface serial 000 interface 0000. His IP address is 10.0.0.2. Subnet master /30 252. Anybody got any questions? If I can't get to it, there's a lot of smart people in the chat room over there. We got my man Dave W still tuned in. Right, he was 10.0.0.1, right? Yep, and then he's 10.0.0.2. Yep, so he's correct. And he don't got no loopbacks. Router B ain't got no loopbacks. So task 1 was to static default route on router B to send all traffic out of the interface. So on router B, we need to create a static default route that's going out of this interface right here. Out of that interface right there. All right, so any kind of unknown traffic, we're gonna send it out this interface right here, right? So we're gonna create a static route, and the way we do that is a quad 0 route, right? Is what I like to call it. Send it out of that 000 interface, right? Remember, your interface might be different. We do a show IP route to verify that. And there he is right there. Task number. Oh, he also said check that you can ping all interfaces. So from this router, we should be able to ping that interface along with this interface and that interface. So we should be able to ping all of those interfaces because of the static default route that we created there, right? Y'all with me so far? All right, so let's go ahead and try to do that. Ping 10.0.0.1, good to go there. Ping 192.168.1.1, we good to go there. And 2.1, we good to go there. All right, so we good to go there. Task 2, configure static NAT on router A. AI practice lab. Listen, man, practice, man. Like, this is the most labbing I've done, like consistently, because you guys make it fun, man. You know, when I'm getting stuck, I just look over in the chat and I'm like, oh shit, you right about that, Kelvin, or you right about that, Professor Black. Why didn't I think of that? Boom, and it works. So you guys help me out, man. I can bring you guys along when I'm taking exams and stuff, man. Just chilling, to be honest. Need to catch up on the rest of this week's videos. I appreciate that, Morgan. But yeah, we typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. So if you can't, watch it live stream, you can always replay it, man. And I appreciate you for watching this stuff, man. So just make you're doing it along with, with us. Even if it's just a replay, get you a copy of the book or whatever, if you can get your hands on it, and then fire up GNS3 or even G, whatever, and then and follow along, because that's the only way you'll kind of learn this stuff, man. Just by watching it, unless some people just have that gift where they can just watch and then remember stuff that way. Not me. I gotta like do it a million times, practice, and actually be hands-on with it. That's how I get better with things, man. So task 2 was to configure static NAT on router A. So go to router A. We're gonna create a static NAT. And then he said any traffic coming from 192.168, any traffic coming from here should be translated to 172.16.1.1. So, oops. He said any traffic coming from here, it should be natted to 172. So once he exits out of that interface, he's gonna have an IP address of 172.16.1.1. And let's see if I remember how to do NAT, because we haven't done that in about 3 weeks, man. But I believe it's Ip Nat, right? source inside. No. IP NAT source static. My bad. Because they said static NAT. Yeah, static NAT. Static. And then inside. No. What's the key word there? Now you got to put in the actual source interface. I don't know where I put inside from. That's weird. Let's do that. Let me see. IP NAT. Oh, that's where okay, so you got to have an inside interface and an outside interface. I forgot about that. I forgot about that. All right, so an IP NAT inside source and then static. The inside local address is going to be 192.168. He said 1.1 should be natted to 172.16.1.1. So now you put the inside global address. Remember, so this is the inside local. Inside global is going to be this one right here. So that's going to be natted to this. There's one thing about these IT terms. They be taking words and make verbs out of them. Natted. The fuck? That's like when they say, what's the other one I be hearing all the time that gets on my nerves? RMA'd. Yeah, we had to RMA that thing, man. All right, so now we put the inside global address of 172.16.1.1. So now we're saying this is going to be natted to that with this statement here. So this is going to be natted to that. That make any sense? And then what else you got after that? I think that's it, right? Yeah, ain't nothing else you need to do here. So we press enter. Task 3, check your configurations with show commands. And there go that NVI interface. Y'all see that? This is a legacy interface that they don't really use much anymore, but it comes up and you'll see that with do show IP interface brief. And there goes that NVI interface right there, 10.0.0.1. So this is going to be our NVI interface. That's going to be basically the interface doing the natting. I think we got to do a don't we got to do an inside interface and an outside interface as well? I think I got to do that. I think so. 0.0.0.0 should be my outside interface. I think so. Go to global config mode. We'll say interface 0.0.0.0. This is IP NAT outside. And then what's going to be my inside interface? What's my inside interface? In this case, is it going to be the loopback? Is loopback my inside interface? So I think this is the outside interface. No. That is the outside interface. So who should be my inside interface? I believe it's going to be loopback. But let me check. That's what I love about this book. There is he said, Kwame coming for you if you tap that ice cream again. I know, man. I'm going to leave that ice cream alone, man. I had 2 big-ass bowls. We going to wrap this up, though, man. This may have been asked already, but this book and its labs can be used in Packet Tracer. Armin, yes, you can use it in Packet Tracer. There's several labs that you can't do, but for the most part, I say a good 90% of the book you can do in Packet Tracer. So yes, you can do labs in Packet Tracer, but some are limited. Yes, exactly. Loopback. So yes, Kobe, I think you was right. The loopback is the inside interface. That's what I thought too. That's what I thought as well. So interface loopback 0 is my IP NAT outside. So I'm sorry, inside. My bad. What am I doing? Fat finger squad. That's the inside interface, right? So this is the inside interface. That's outside interface. I'm gonna check the book and see what he got in his solution. But he also said check your configurations with show commands and pings sourced from 192.168.1.1 when you have debug IP packet running on router B. So we got to go to router B. debug IP packet, debug IP packet. I guess I could have done that too. And now we're gonna ping sourced from this. So we're gonna ping from there to there, right here. All right, and then it should theoretically be natted. So it's gonna go from here, get natted to this, and go to that, and should show the source interface as this instead of this. Right? I know there's a lot of writing there, but that's what we're gonna basically have there. So let's ping 110.0.2. We're gonna change the source interface. No, you can't do it that way. How you do it? You just do source like that. 192.168.1.1. We got a reply. We'll debug IP packet, and there they go right there. And we'll see the source. We scroll up. Source is 172.16.1.1. So when we pinged from here, when it went through the interface of 0.0.0.0, it got, yes, natted, right? Network address translation. And he changed his IP address to 172.16.1.1. So this is kind of like, even though this is a private IP address, but they just did that for a reason. Typically, you would have a private IP address translated to a public IP address. And then he came across here, reached the destination, and notice his source is actually 172.16.1.1 and not 192.168.1.1. Destination was 10.0.0.2, which was this interface right there, right? .2, which is that right there. Oops, move that out of the way. .2, see? That is the destination. Length, I think that's the size of the packet. What else we got here? All this other stuff, I'm not even sure. I can't even remember what all this is. MTU is 0. That's maximum transmission unit. And the rest of it is pretty much the same. And then it went back the other way. So source was 10.0.0.2, which is that. Destination was 172.16. So when it came back over here, he said the destination was 172.16.1.1. And that was pretty much it, man. So, and then he did it 5 times because we sent what? 5 pings. So that's pretty much it for that lab. We could also run another show command over here. What? Show Ip Nat Translations. And there goes the translations, right? Inside global address is 172.16.1.1. Remember the global. It's inside global. I know it sounds like it's on the outside interface there, but this is the inside global. The inside local is 192.168.1.1. So this is the inside local. So inside local, inside global. This would actually be the outside global. And if we had something in here, that would have been the outside local. But we didn't. We only hit this right here. So technically, that's actually the outside global address. And yeah, that's pretty much it, man. Y'all run with that like button, man, if y'all like what y'all see. Tomorrow, we're going to do challenge lab number 5, which is NAT pool. So we're doing the same thing as this, but it's not a one-to-one mapping of IP addresses. It's just it picks from a pool of IP addresses before it exits out of the interface, and that's pretty much it, man. Y'all want with that like button. Make sure y'all tune in Monday through Thursday, 8 p.m. Eastern Standard Time. But I'm gonna be streaming all weekend, man. So tune in to your boy, man. For now, comment, like, subscribe to the network.